Hello, welcome to Jamro's Electronic Solutions. We have come back again with another video here. It's a simple video that we just want to show. It's not going to take long. We want to talk about these Lambda sensors. Okay, so it's a 4-wire Lambda sensor. It is important for you to take note of these colors. You see, we have got 2 white ones at the bottom there, and then we have got a gray and a black. So let me walk you through what these wires do. So one of these white ones is a power, the other one is a ground. The black wire is a signal wire, and this one is a ground. Okay, so if one of the wires is not working, the white wire is not working, the sensor will not work, because it needs to reach at least 300 degrees in order for it to work. So these are for the heater. The 2 white wires, they heat the sensor so that it functions quickly. This is a zirconium element, so it needs heat for it to work properly. So what we want to show you is how to test this sensor. So I will disconnect it for now. This side here comes directly from the sensor. That's the one that is down there. You can see it where my finger is pointing. That's your sensor there. So this side is the sensor side, and this side on my left hand is the ECU side. So we want to test both. So the first thing that we want to start with, the sensor side. Let's check resistance on the sensor side. And when you check resistance on the sensor side, you want to check resistance on these 2 wires here, okay, because they are the ones that go through the coil, and that's where the resistance is, on the heater coil. So I will get my meter. So resistance, usually it should not go beyond 10 ohms. You want 5, 6, 7 thereabouts usually. Let's check this one and see if I'm right. I need to select resistance scale. Okay, so let's come to the sensor and see. There you go. We have got about 4 ohms, right? So that's good enough. 4 ohms is good enough. You don't want to see more than 10 ohms on this thing. It will start to give you problems. So the resistance of the heater is okay. So if you get 0, if you get OL when you're checking these 2, it means that they are open. Okay, they are open. If you get OL, it means that the heater is open and the sensor will not work. You'll have the engine management light sitting there on. So what we want to do is we want to check these wires from the ECU now for voltage. Let me see if they are numbered. I don't see any numbers here. Maybe this side, but it doesn't matter with an O2 sensor, as long as you can match your signal. If you can see which one is your signal, which one is we can judge by this side. So that's the good thing. So when let me see, that's how it goes in. Okay, so so between these 2 here, which is any of these 2, for on my left, it should be power. Let me find a ground first, and then I'll show you how to test this. Ignition key is on. Ignition key is on because now I'm going to check. I'm going to check for voltage. I've even changed my scale now to voltage. So one of these should be 12 volts. So let me check on one of the white wires. Let me see. It's giving us 4 volts. Yeah, Here's the other one. That is 12 volts. So one pin there is 12 volts. Let me go to the other pin. We shouldn't get any voltage. Yep, that's 0.4. That's okay. And another one again, it's 0. That's fine. So it seems like this one at the bottom is our power. That's 12.25. Okay. Let me put this thing here. Right. So if we have 12.25 here on one of the heater wires, bear with me. One of the heater wires has got 12.5. Let's see the other one, which is supposed to be ground. The ground side is sitting at 4 volts. Okay, different manufacturers. This is BMW, by the way. This is BMW 325. It's a petrol engine. Okay, it's a 6-cylinder. And with some of the manufacturers, you'll find 0 there. But BMW has got 4 volts there. Okay, so let's see then when we connect. Let me turn the ignition key off. Okay. We're going there. Let's see what we have. Oh. What I did to my right, the key is off. Let me turn it on. So I'm going back to the same white wires. Okay, we've got 12 volts. That's the one that we said we have 12 volts. Let's go to the one that had 4 volts. Let's see what has happened to it. Look now, we have got 12 volts on it now connected. So which simply states that the 12 volt, because there is no ground, the 12 volt on one side will go through the element and then come on the other side. So this 12 volt may be switched. From the look of things, it may be switched. So the one on the ground side, it should be switched. We'll see. I'll use a scope there to show you what is happening. So let's go to the other ground here, which is a gray one. Should be 0 point something. Yeah, 0.056. Okay, and let's go to the signal wire. Our black wire is the signal wire. Okay, this is the most important wire as well. You can see it is sitting at 0.4 with the ignition key on, right? The ignition key is on. It's sitting at 0.42. Right. Now the engine is running. I'll go back to the white wires. You can see that we've got 13.4 there. That's battery voltage. All right, that's one of the white wires. Let's go to the ground side. We now have got 0.5. You notice that it's now providing a ground. It has dropped. Let me see if I've got good contact here. It's important that I've got good contact. So see now, we've got 0.5 volts, 0.49, 0.5 volts. That's the ground side. Right, I'll check with the scope and see if it is switched. Right, okay. Right, we want to look at the ground. 0.04. Remember, this is the ground, this is the sensor ground, not the heater ground. That's your sensor ground. So if I go to the signal wire now, that black wire, I'm not writing down because I'm thinking this, it should be easy to follow. Look at the signal. I want you to watch that signal. You see what it's doing there? It is switching between rich and lean. 0.2 is lean, 0.7 is rich. Okay, remember this is the pre-ket sensor. That's what it should do. Let me get a piece of paper and explain something here. Right, here's what I want to show you. This pre-ket here, the ECU will cause it to cycle between rich and lean. Okay, so you've got your 0.2 coming sometimes 0.8 volts. Remember, this sensor is a 1 volt sensor. That's a zirconium sensor. It is a 1 volt sensor. And it is the sensor that is producing this voltage. There is no ECU here that is helping this, that is giving this sensor a voltage. It is the sensor that is producing this volt up to 1 volt. So this sensor this side, you want to see it. If we have a scope, we want to see that. So that's your 0.2 here and maybe up to your 0.9 there. Okay, and then you have got your stoichiometric around 0.45 thereabouts. Okay, so you want to see that it has to change. If it's stagnant, if it stays flat, then you know that there's a fault with this sensor. But when you come to the post one, you want to see something like that, almost a straight line. It's an undulating line. You know, you don't want to see this. If you find that this O2 sensor, the post ket, is also going like that, then you know that condemn that ket. It's the catalytic converter, it's gone. You don't want that. That and that means that the ket is gone, right? But that and that means that the ket is good. These are just basics. There's more information that we can go to here, through here. So I thought I should show you this so that you know this has got, you don't want this one fixed like that. Okay, you don't want that. You want this one going up and down like that. Okay, so rich lean, and then it finds the stoichiometric. Stoichiometric is not fixed only on 0.45. You can have your, it's a range that can be, you know, between that area there, right? All right. So this one is switching on and off. I'm happy to see that my signal wire is actually going 0.1. I saw the minimum that I saw there was 0.1. You see that? 0.18. So that's very good. This is very good. Okay. Remember, this is pre-ket. It's that one there. Okay, like the way this BMW, this 3 series is set up is you've got 4 Lambda sensors. You've got 2 that are, they are pre-ket, and then you've got 2 that are post-ket. So what I've done now, I've gone on this one here, that's the pre-ket, and I'm on that one there, which is the post-ket. So if a post-ket is working right, it should report rich all the time. It should be rich all the time. It should not switch on and off like the first one would do. So as you can see, it is almost a straight line. Look where it's going. We read the red channel this side. Can you show these numbers, please? See that? 0.6. That's where it comes. You check that. Check that red channel. It goes to 0.6. See in there? There you go. That's where it is. And the blue channel is the one that is switching rich and lean, rich and lean. So this is the first set. Let me go on the second channel and show all the 4 channels, so that we want to see 2 channels switching like that, lean and rich, lean and rich. And then we want to see 2 channels going up straight. The is going to be another pre-cat. So that's the green one. It's beginning to rain here. This one is going to be my channel 3. Maybe I need to move my machine. So I've connected all the 4 channels. As you can see, they are all connected. Channel 1, 2, 3, and channel 4. If you notice, our catalytic converter is working fine, because the blue channel is switching from lean to rich. Okay, but look at the other, the post-cat in red. The post-cat in red is reading 0.6. Okay, then we go to another set, which is the green, okay, and the yellow. So the green is switching, if you notice, 0.2 to 0.8 perfectly fine. It's switching on and off, on and off, on and off. And then you have got your yellow. Look at what the yellow is doing, undulating. This is what you want to see. It just undulates like that. Let's follow it. That's the scale for the yellow. You see, it should be rich. See that? 0.7. Okay, so it's brilliant. This is nothing wrong with this catalytic converter. It's working fine. This is what you want to see. You want to see the pre-cat switching, which is the blue channel and the green channel. They have to switch. They are the pre-cats. This is a 6-cylinder. So one of the Lambda sensors is allocated to 3 cylinders. One of the pre-cats. The other one is allocated to another 3 cylinders. Then the second lot, which is the post-cat, one is also allocated to 3 cylinders. So you have a system that is working fine. This is what you want to see, and I'm happy. I'm looking for the reason why I'm testing these. I'm looking for a misfire. I just wanted to check my Lambda sensors and see what they do. I haven't looked at the fuel trims. I'll check the fuel trims next, but I just wanted to show you guys, if you are using a scope, you want to see about, the first one switching, and then the second lot just staying almost flat. Let me just tap into the second lot with the multimeter so that I can show you that. At the multimeter, I'm on the post-cat Lambda sensor. So look at our voltage. You see it better on the multimeter. See, it's staying almost flat at 0.6. That's almost flat. All right, that's what you are seeing on the red channel there and on the yellow channel. You do not want to see both the yellow and the red, which are post-cat, switching like the pre-cat one. Once that happens, then you know that you have got an issue with your catalytic converter. But in this case, I'm happy with what I'm seeing right now. Look, if you've got any comments, please send the comments. Let's discuss this. There's more information here to be talked about. It doesn't just end here. You'd want to see the time, you know, how long it's taking it to switch as well. That is actually important.